These are the lesson 3.4 notes on the distributive property. These notes are a little bit long and they're also really important. All right, we're using the distributive property and we are combining like terms to simplify expressions. And that is a really important thing to understand and be able to do before we move into the algebra unit. The distributive property tells us that when we want to multiply a sum or a difference, so an addition or subtraction problem by a number, then you multiply each number in the sum or difference by the number outside the parentheses. So let's look at what that looks like with numbers. That means if you have 3 times the group 7 plus 2, you would multiply 3 times 7 plus 3 times 2. And if you have 3 times the 7 minus 2 in parentheses, then you multiply 3 times 7 and subtract 3 minus 2. Now, when you have numbers, if this was just numbers, you would probably add them together and then multiply by 3, right? Because you know you're supposed to do parentheses first. The trick comes that when you are solving an equation or simplifying an expression, that you have variables in it, and you can't add the B and C together because you don't know what they are. So you have to multiply whatever is outside times B, and then add, and then the A times the C. And if it was subtraction in the middle, you would do A times B, subtract A times C. All right, let's look at that. So the first example just has you doing mental math using the distributive property with numbers, all right, just to see why that works. So 8 times 53, that's the same as 8 times 50 plus 3. 53 is 50 plus 3. So I can break that down, and then I can multiply 8 times 50. 8 times 5 is 40. And then I add on that 0, so 8 times 50 is 400. And 8 times 3 is 24. So 8 times 53 is 424. Right? You have 3 you tries like that. We'll do 5 times 40 plus 1, 9 times 10 plus 9, and 6 times 30 plus 7. So just break it up. All right, then we'll apply a similar strategy to working with fractions. We've done this before when we were multiplying fractions. You have 1/2 times 2 3/4. That's the same thing as 1/2 times 2 plus 3/4. So now we can do 1/2 of 2. What is 1/2 of 2? Oh, that's 1 plus 1/2 times 3/4. Maybe I'll go do some side work. 1/2 times 3/4 equals 3/8, and that doesn't simplify. So just do 3/8. 1 and 3/8. We'll just briefly point out this works. You can multiply the fraction times the whole number and the fraction times the fraction because there is not another whole number here. This is not a mixed number. You cannot do that strategy when you are multiplying two mixed numbers together because you end up leaving out parts. So if you're multiplying mixed numbers, you have to change them into fractions first. Okay. We've had a lot of struggles with that. Okay, but here we just have fraction times mixed number, so you should break these apart. All right, now we get to the fun part. We'll use the distributive property to simplify algebraic expressions. So now we have a variable inside. You have to multiply the number outside the parentheses times everything inside the parentheses. 4 times n is 4n bring down the plus, and 4 times 5 is 20. And then you stop, all right? You can't put those two things together because the 4 has an n. This is 4 times n, so you cannot combine it with the 20. All right, then we're going to do 12 times 2y. 12 times 2, so we're just going to multiply the number parts together. So you do 12 times 2 is 24y. This is like saying I've got 2 y's and I have 12 of them. If I have little groups of 2y and I have 2y and 2y and 2y and 2y and 2y and 2y and 2y, I have 12 groups of 2y, that would be 24 y's. And still subtract, and then 12 times 3 is 36. And again, you can't combine. You have to stop there. You can't add the 36 in with the 24 because this term has a variable and this term does not. You can only combine things that have the same variable. And then for C, we have, we have 3 terms, but you do it exactly the same. So we're going to do 9 times 6, that's 54, plus 9 times x is 9x, plus 9 times 2 is 18. Now I do have two things that are alike. This term has a variable in it. Let's pull that over by itself. But these two terms are constants. They're numbers. You can add the two constants together because they're alike. They are like terms. So we have 9x plus 54 plus 18. See, 8, 9, 10, 12. 3, 1, 2. Is that right? Yep. Okay. You are allowed to use a calculator now, or you can do a little side work. Right? And again, you have to leave it like that. You can't combine the 9 with the 72 because the 9 is attached to a variable and the 72 is a constant. They're different. They are not like. Okay, you have 3 problems just like that. And then we have our real life application. All right, so we have Jose is 6 years old. His brother Felipe is, or I guess this is Felipe, is 2 years older than Jose, and their aunt Maria is 3 times as old as Felipe. Write and simplify an expression that represents Maria's age in years. So describing Jose, he is X years old. Jose is X years old. And so the expression for him is X. What do we know about Felipe? Felipe is 2 years older than Jose. So if Jose is X, then Felipe must be X plus 2. What do we know about Maria? Maria is 3 times as old as Felipe. 3 times as old as Felipe. So how can we write an expression for Maria? Well, we can take Felipe's age, which is X plus 2, and we can multiply that by 5 because she is 3 times older, not 5 times older. Try that again. Did we get everything right that time? All right, now we want to write and simplify an expression that represents Maria's age in years. So we have written it, but now we need to simplify. All right, so we're going to stretch it out. She's going to be 3x plus 3 times 2 is 6. So if, let's pick a year, say when Jose is 1 year old, when Jose is 1, then that means that x is equal to 1. So let's substitute a 1 in there for x. Whoops, I did not need those parentheses. I'll do it like that. Let's see. Okay, so when Jose is 1, how old will Maria be? She will be 3 plus 6 is 9. Does that make sense? Let's see. If he is 1, then Felipe would be 3, and Maria is 3 times 3, which is 9. It worked. This is called substituting. That's verifying and substituting and checking to make sure that my answer was correct. Okay, and then you have a similar problem. It's set up the same way. Alexis is X. Her sister Gloria is 7 years older, and their grandfather is 5 times as old as Gloria. Right, so we're doing a similar problem. All right, and now we put it all together. To simplify the expressions, you have to combine like terms. So you can only combine means add or subtract terms that have the same variable. Okay, you can only add or subtract terms. That means combine. That have the same variable. We call that combining like terms. This is the thing that kids miss a lot. They will try to combine things that are not alike. All right, so if you know that that's a place where you could make a mistake, then be extra careful. Right? So when I look across at 3x and 9 and 2x and I'm subtracting 5, I see some things that are alike. I see this has an x in it and this has an x in it. Those have the same variable, so I should be able to combine them. So I'm going to rewrite this and I'm going to use the commutative property to rearrange the terms. So I'm going to put the x's together and I'll put the 9 over here and I'll still subtract 5. So now I've got 3x and 2x. Those both have x's. 3x's plus 2x's makes 5x's. Plus 9 minus 5 is 4. And then you have to stop. You can't combine the 5 and the 4 because the 4 does not have an x on it. They are not like terms. Look at B. You have a y and a y and a y. Those are all y's. So you can combine those y's. I've got 1y, 2y, 3y's. Remember, the coefficient in front of that y is an invisible 1. I don't have to write the 1, but I have 1y and another 1y and another 1y makes 3y's altogether. And then we have one that has everything together. You distribute, and then you're going to combine like terms. All right. So the first thing you see is I've got these parentheses but one's got a z and one's got a y, so I can't do any of this addition and subtraction here. Let's just bring down the 7z and the plus, and then let's use our distributive property to multiply 2 times z, which is 2z. Bring down the subtract, then 2 times 5y. If I have two groups of 5y, that's 10y. So I'm just multiplying together the coefficients and then bring down the variable. And now I don't even have to rearrange because I've got the 7z and the 2z are right next to each other. They both have the same variable in them, so I can add those two together. 7z plus 2z is 9z minus 10y. I can't combine z's and y's together. They are not alike. They are not like terms, so you have to stop. Okay, and then you have 2. This one probably isn't too hard because there's no distributing. This one is a little bit trickier. Distribute first, and then add the b's in with the b's and add the 2 in with the constants.